have the zero factor property because it's going to be that extra thing we need in order to solve. Fill in the blank. Negative 18 by how much equals 0? 0. 18 zeros make 0. How many 22 times is 0? Well, only 0 22 times is 0. Fill in the blanks. Something times something is 0. Well, let's see if I can come up with some. Let's see. How about 7 times 0? Got it. How about, I don't know, negative 2 by 0? Yeah, so filling in this second blank, if I put a 0 there, I can put whatever I want to right here. 7, negative 2, negative 2,307,000. I don't know why I'm stuck on 7s right now, but still, right? But then, that was this. But what if I put a number in the second spot here? So let's suppose for fun I do something like something times 17 equals 0. Well, all I would have to do is put a 0 here, yes. Or I could do something like 0 negative 3,422 equals 0, and that, right? So, I mean, as long as I have a 0 here, it doesn't matter what I put over here. And as long as I have a 0 in the second factor, it doesn't matter what I put in the first factor. So either the second factor needs to be 0 or the first factor needs to be 0. And also, I do believe that 0 sets of 0 does in fact give us nothing still. So it looks like either the second factor has to be 0 to multiply to 0, or the first factor has to be 0 to multiply to 0, or both factors are 0. Okay, so let's write that down. At least one factor must be 0 for this to be equal to 0 after being multiplied. Must be 0. Yeah? Okay. So our answer, we can't really fill in the blanks, but we know that this is how we would fill in the blanks. At least one of these factors must be a 0. Okay. And now let's fill in the blanks for something times something is 24. Good. Well, here's one possibility. 1 by 24. So either 1 added 24 times or one set of 24, however you want to read this. That's 24. 2 12s is 24. 3 8s is 24. 4 6s is 24. And this was just whole number positives to multiply to 24. What if I said this? Half of how much is 24? Half of 48 is 24. What about a tenth? 1/10 of 240? A tenth of 240 is 24. And I didn't even dip into the negatives. So right now I have 1, 2, 3, 4, 5, 6 possibilities. And that, I mean, I could have as many fractions as I wanted to. I could go positives and negatives. There are actually infinitely many possible answers to filling in this blank. There are infinitely many ways to answer this correctly. Whereas if we did something times something equals 0, at least one factor must be a 0. So it indicated to us one factor must be a 0. It gave us a direction, whereas here, it didn't really give us a direction. One factor doesn't have to be 24. One factor doesn't even have to be a whole number. One factor doesn't have to be a positive. One factor doesn't. So this is so much flexibility. So a factor times another factor, their product being 24, I mean, that's a really loose constraint. We could do whatever we want to. Like, we have, this is a situation where we have no parents and we have no law. Yeah. However, this is, I mean, there's a little bit of flexibility, but there's a law. Like, at the end of the day, you take these two things and you get 0. So that means at least one of them had to have been a 0. Okay, so now let's solve some business. Because what you see below then is that you see a bunch of things set equal to 0, right? The next few problems are all set to 0 because if we're multiplying two things and they equal 0, at least one must have been 0. Okay, so solve this provided it was equal to 0. Well, that's nice. 4. 4 minus 4 is 0. Got it. Ooh, 2x plus 3 equals 0. So I'm going to go ahead and make 2x equal to negative 3 because negative 3 plus 3 is 0. So 2x equals negative 3. Scale down. If 2 of these is negative 3, then half of that is what we want. So that means x is negative 3 split into 2, or negative 1.5. Now, I would like to go back. Nope, I don't have to go back. It's written right here. Of course it is. So now this is saying if we have these two linear factors, x minus 4 times 2x plus 3 equals 0, and we know that at least one factor must have been 0 because we have something times another something equals 0, then either x minus 4 equals 0, or, because at least one factor must have been 0, or 2x plus 3 is equal to 0. Or both, but I doubt that's going to happen. And in this scenario, we solved it. We said that's when x equals 4. Okay, so that is when. So that happens when x equals 4 or x equals 1.5. So what we saw up here in number 3 is at least one factor must be 0. So we have this factor by this factor, and that equals 0. That means one of them had to have been a 0. And in number 5, we solved that equation. So that was when x equals 4. And in number 6, we solved that equation when it was set to 0. And we saw that 2x plus 3 equals 0 when x equals 1.5. Now, I'd like to take you back to our first example and notice that we actually saw that on the graph. Here was 4, making this first factor 0, and here's negative 1.5, making the second set of parentheses negative or 0 by when x is negative 1.5. So we did see it visually, but now we see it just algebraically. If two things multiplied are 0, either the first thing is 0 or the second thing is 0, and we just find out what x's make that happen. Okay, let's do that again in number 8. In number 8, we actually have 3 things being multiplied to being 0. Well, if 3 things are being multiplied to get 0, then one of them has to be 0. Let's write that out. So either 2 equals 0 or 3x plus 5 equals 0, or x minus 6 is equal to 0. Well, in the first scenario, that is just not feasible. So either, no, that is not going to happen. Bink, bink. Right? 2 is not 0 in terms of real numbers. Or 3x plus 5 is equal to 0. We can solve that. Let's see. Then, so that is when, that means that 3x has to be negative 5 because negative 5 plus 5 is 0. And scale it down, x equals negative 5/3. Might as well just leave that. Or here, x equals 6. So this happens. So these are true when x equals negative 5/3 or x equals 6. So in order to solve this equation, we knew that either 2 had to be 0, 2 times this, 0. 2 had to be 0, 3x plus 5 had to be 0, or x minus 6 had to be 0. So if we were to plug in x equals 6, we would have 2 times, 18 plus 5, I think that's 23. We'd have 2 times 23 times 0, which equals 0. And that's true. And the same thing would happen with negative 5/3. 3 of those would be negative 5. So we would have 2 times 0 times negative 23/3, I think. I just did head math. Forgive me. So, but in number 9, well, that's a little interesting. We have 3 things in there being multiplied by to get 0. So at least one factor must be 0. So either 3x equals 0, which can happen, or x minus 2 equals 0, or 4x plus 3 equals 0. If these 3 things are multiplied to get 0, one of them had to have been 0. And that happens when here x is 0, here x is 2, or let's see, 4x would be negative 3, scale it down by 4. Yes, so this one actually had 3 possible outcomes in terms of x values that would make that happen. Okay, let's look at number 10. I see 2 factors, so only 2 possible outcomes here. So this happens when, so just going with this, at least one factor must be 0 business, when either x minus 3 equals 0 or x plus 7 equals 0. And that is when x equals 3 or x equals negative 7. Just to bring that one back, I swear we did that one too. Here. Yeah? X plus 7 times x minus 3? 3, negative 7. There they are. Right there and right there. The things that make this equal to 0. So, x plus 7 by x minus 3, or x minus 3 by x plus 7. Solutions, 3 or negative 7, make it 0. Or make our y value 0? Okay. Ooh. Let's do it again. Oh boy. Solve x squared plus x minus 21 equals 0. Oh boy. So when I look at this, I think to myself, I could start guessing and checking, but I'm a little bit at a loss because I notice that when I look at this, I'm like, well, if there were two things multiplied, I would say that at least one factor must be 0. But even if this term is 0 and that term is 0, then this still won't work out because 0 plus 0 minus 21 is not 0. So I could start guessing and checking to try to make this plus this equal to 21. Or I could think about it in these factored forms. So we would go with this, and then we would do this either or business. So either or, right? So now I'm going to look back. Did we do this one? I swear I remember seeing that. Hold on. There. We said that x squared plus 4x minus 21 was x plus 7 times x minus 3. X squared plus 4x minus 21 was x plus 7 times x minus 3. That was example 1, number 4. Let's write that down just in case you're like, what? What? So example 1, number 4. We actually verified this. Well, that means either x plus 7 equals 0 or x minus 3 equals 0, and that happens when x equals negative 7 or x equals 3, which happens to be the same as this, yes? And has that graph. Oh, how does the solution to x squared plus 4x minus 21 equals 0 match with your graph of x squared plus 4x minus 21 in example 1? Well, the 3 and the negative 7 are exactly where it crosses the x-axis. So the graph of each of these, when we set y equal to 0 and we say x squared plus 4x minus 21 equals 0 instead of equals y, we get these two locations where it had hit the x-axis. Let's write that down. So, how does it match the graph? Solutions found in the factored form using the zero factor property are the x-intercepts of the graph. So instead of having it equal 0, having it equal y and graphing it, those are the same. The solutions found by the factor form using zero factor, same as the x-intercepts, of the graph. Beautiful. So, really quick, let's define this zero factor property. Okay, so if two or more numbers multiplied and their result is 0, then one of them had to have been a 0. That is the zero factor property. If two or more factors, numbers, because remember, even x's are numbers. If two or more factors are multiplied, and result in 0, with a product result of 0, then one of them had to have been 0. Okay. Now, as a quick remark, we can graph, factor, or guess and check to solve these quadratic equations based on our new tools. So we can graph, factor, or spend our whole day guessing and checking. To solve these quadratic equations now. And before I also need a quick little, I guess it's a disclaimer. These aren't the only way. There's going to be another way, which is the quadratic formula. And that's when all of these become too tedious, or, these are actually our first steps. Like, this takes a long time. Usually guess and check actually takes a long time. So then we were like, you know what? There's got to be a better way. But graphing sometimes takes a long time too. So factoring was developed because it's just quicker. It's just quicker with less writing and less room for error. And then if all of these start to be hard, then we bring out the sledgehammer, and that's the quadratic formula. So in the next video, we are going to practice our factoring so that we can maybe avoid doing a bunch of tables of values and a bunch of different plotting of points, and just see if we can do it algebraically, because it's fewer computations and fewer steps.